Hello everyone. Today let's speak something about flowers. As you can see, I have brought up three kinds of flowers here, which may look similar but those are not equal. So first one is versicolor, second one is setosa, and third one is virginica. So as you can see, the classifier parameters or the parameters on which these flowers can be classified is the sepal length width, or the petal length width. On based of these length and widths, we can classify what kind of flower it could be. So as you can see in the versicolor, the sepal length width, petal length width is higher than the other two flowers, the setosa and virginica. But why are we talking about these flowers is because we are going to analyze the data set which is of these flowers, which Scikit-Learn provides us. So let's look at it today. Let's import the data set from sklearn.datasets, and the name is load iris. So this is the data set load iris which we are going to analyze today. Load iris, let's see what it has. So it is giving us a series, an array, not the data frame. So if you want to look at the data frame, we have an attribute called as frame, which has the boolean value. We can say true here. Okay, and we can see here a data is here, a frame. What else is there? Let's see what data provides us. Okay, so we have four features, four columns: sepal length width, petal length width, and where is the target one? Feature is also there, not feature, frame. Okay, so as you can see, the last one is the target, which is the dependent variable or dependent feature, we can say, and it has values such as 0, 1, or what all the values it contains. Let's see. Let's put it in the df first, then df unique. So it has three unique values, 0, 1, and 2. But what it represents? It represents this. Let me show you. It represents those. Yeah, see these target names. Let me print that. See, the 0, 1, and 2 represents these three flower names: setosa, versicolor, and virginica. Now let's visualize this. Let's plot a scatter plot and see how these flowers are classified based on its petal length and petal width. For that, we'll need Seaborn, import Seaborn as SNS, and we can visualize it. Visualization. Let me decorate this document a bit. Segregating the data. Okay. In visualization 1, let's plot a scatter plot, which will need a data frame, and then x would be sepal length, x would be sepal length, which needs to be in single quotes, and y would be sepal width. Okay, now we got the scatter plot here, but the thing is we are not able to classify which dot represents what. So for that we have something in the scatter plot which is, see this hue, and in this hue, is it a boolean or what? Hue in smoker. I think in hue we need to pass the target one. Yes, see, again there is a little problem, which is we can now see the 0, 1, 2. It represents 0 represents the setosa, 1 is something else, second is something else. Now we are working on this, that's why we knew it. But what if some other person looks at it and he or she does not get it? So for that, let's do one thing. Let's put one more column in this data frame, which would be target flower target dot apply. Here we can use lambda. What was those three names? I forgot. Okay, so 0 would be setosa if x is equal to 0, else versicolor if x is equal to 1, else virginica. I found this syntax a bit weird, but anyway, now let's print this data frame. Okay, we got that target flower as our feature. Now we can put it here, and now see, now it's bit more clear to the viewer what it actually represents. So we can see that the setosa one, the blue dots, have the less petal length, sorry, sepal length, but it has higher sepal width. Which one is it? Setosa. Okay, lower sepal length, but it can have more sepal width. And these other two, versicolor and virginica, are a bit gathered together. Anyway, and but we have plotted this scatter plot based on sepal length and sepal width. But what about petal length and petal width? Let's do that also. I have copied this here. Now petal length and then petal width. See, now this is more clear when we visualize it based on the petal length and petal width. See, the setosa has lower petal length and lower petal width. Versicolor is somewhere in between, and virginica has more petal length and more petal width. Setosa, versicolor. Okay. Now let's train our model, which is of logistic regression, and then see how that model behaves or predicts the values when we feed this data to it. Scikit-Learn dot linear model import. Now the model would be of logistic regression. Training the model logistic regression. We can say before training the model we have to do one more thing, which is by using train test split we have to split the data in training and testing sets. For that, Scikit-Learn dot model selection import train test split. Segregating the or classifying the data. Here I can use train test split, and here I have to classify it. So X would be, we do not need these two columns in the independent variables. These four would be there: sepal length, width, petal length, width. For that, what I'll do is I'll use drop, and in this drop I have to pass these two columns. First one is target and second one is target flower. This is the problem, not found in axis. Okay, I have to give axis also. Axis is equal to 1, fine, which is working fine. And in the y variable, which is the dependent one, we'll pass the target. Okay. Now in this train test split we can pass x, y, then test size would be, let's say 25% will go in the test, and we also have to pass this random state. This could be any value to make sure of the reproducibility. In return it will give us x train, x test, y train, and y test. Fine. Now let's train our model. Model dot fit x train, y train. Model is trained. Now let's calculate the score it has. Model dot score. You have to pass x test and y test, which is very simple. 100%. I mean, it's fine. It's really fine, but how could it give 100% score? Let's do one more thing. Let's plot the heat graph from the Seaborn. Heat graph. SNS dot heat map, sorry, not graph. Now this heat map will take a confusion matrix. Confusion matrix is one of the metrics in Scikit-Learn which we can we can make use of Scikit-Learn dot metrics import confusion matrix. Now here I can make use of confusion matrix. Now confusion matrix will take two parameters as any of the, what is this, confusion matrix. Confusion matrix will take two parameters as of any of the metric, which is y test and y prediction. Y test and y prediction, but we do not have prediction yet. So for that, let's model dot predict what, x test, which in return will give y pred. We have the confusion matrix here. Let me name it as confuse mat. Run it. We will also need anode. We have done this before. Anode is equal to true. What happened? Is equal to true. As we can see in the diagonal, all the values are here, but nothing in the other columns or other boxes. That's why it is giving us 100% score. Now this is fine. Now in this video, what we have done is we have analyzed the data frame, which is load iris. We have plotted the scattered graph in order to analyze the points, the dots, how the flower is classified based on these parameters, which is petal length, petal width, sepal length and sepal width. And later we have evaluated our model, which has given 100% score, and we also have plotted it on the heat map in order to verify whether it is correct or not. And we can see on the diagonal, let's decorate it a bit. So there is xtick labels. Before doing that, names. Here we have 3 names. And what were those names? Setosa, versicolor and virginica. Versicolor and virginica. We have to pass it here in xtick labels. Names, see, Setosa, versicolor, virginica. Same we have to do for the y-tick labels. Names. So on the y-axis also we have these 3 names. I'll showcase what it does and what it's doing. Before that, let me import one more thing. Import matplotlib dot pyplot as plt. So here we can have plt dot x and y labels. So x label would be predicted values, and y label would be true values, actual values. So what this heat map shows us here, for the first column, the Setosa one, we have said that the 15 instances we have found such that we have predicted the flower is Setosa, and in actual it was Setosa. Same for versicolor and virginica. So our model predicted that 11 instances are there where we have found out that the flower is versicolor, and it is actually a versicolor. The true value also given here, versicolor. Same for virginica. but none of the other columns we have not made a mistake. Our model did not made any mistake for predicting the flowers. I want to do one thing here. Instead of giving 25% as test data, let me give 50% as test data. Let me run it. Let me run this one. Model score. Let me print the model score. Model score is still 1. What if I increase it to 70%? See, now the score is 0.96. Now it should give a little bit error here. See, for the Setosa it is same. For the 40 points we have said that it is Setosa, and it is Setosa. For this one we have predicted versicolor, but it is actually a Virginica. And for this one our model predicted it is a Virginica, but actually it is a versicolor. So based on this test size, we can say that it is giving us a bit error here. Now which should be fine, but anyway it's performing well. 0.96 is not bad, it's fine.